The mean score of native English speakers on the SAT verbal portion is 495. A sample of 96 SAT scores from students whose native language is not English was selected. And those scores had a mean of 482 and a standard deviation of 24. Use a 0.2 significance level to test the claim that the mean score of non-native English speaker is different from 495, the mean score of native English speakers. Okay, let's see, a couple of things to look at here that I'm going to highlight. For starters, we're talking about the mean scores in each of these. So the variable that we're going to use is mu for mean. And the claim here is that, let's see, test the claim that the mean score is different from 495. So that mu is not equal to 495, which is the score for the native English speakers. So our claim is that the mean is different from 495. The opposite would then be that mu is equal to 495. Now we have to identify which hypothesis these go with. So the first one, since it's a not equals to, this would correlate with the alternative hypothesis. Mu is not equal to 495. Oh, let's make that prettier. And the following one, since it has the equality, would be the null hypothesis. Mu is equal to 495. And it's always, when we reject or fail to reject, it's the null hypothesis that we're rejecting or failing to reject. Okay, it looks like this problem, we always have to find the test statistic, and this problem is asking us about the mean. So since this is really, really important. Oh, sorry, I missed one thing. Since it's not equal to, this test is a two-tailed test. Okay, on to the test statistic. Always have to find that regardless of whether you're using the p-value method or the critical value method. And in this case, the test statistic, we're going to use the student t test statistic because we're dealing with means. So whenever we're dealing with means, we're going to use the student t test statistic. So one other reason is because we do know the sample standard deviation, but not the population standard deviation. And if you remember, that formula was the sample mean minus the population mean divided by the sample standard deviation over the square root of n. That is going to be our test statistic. Okay, so when we plug this in, we've got, let's see, x bar, our sample mean was 482 minus the 495 for the population we're comparing to, over the standard deviation was 24, divided by the square root of, let's see, there were 96, it says 96 SAT scores. And when we plug that into our calculator, we get negative 5.3072 for our test statistic. It says it rounds to 3 decimal places, so we would plug in negative 5.307. Okay, now we have to find the p-value. Now, the p-value is difficult to find sometimes for student t distribution because if you're using technology, you're in good shape. If you're using technology, you can use spreadsheets, you can use your TI-84 and figure out what the p-value is. If you're not using those things, it can be kind of challenging. So I have a copy down here of the student t distribution chart, and I want to remind us of a couple of things. I want to remind us, first of all, that we're in two tails. So these are the values that we'll be looking for. These are the p-values we're going to be looking for. And down here, these are all of the t-values that we match them up with. So we're going to have to do a little estimating, but all we care about is whether this p-value is bigger or smaller than our significance level. So if we scroll all the way down here to, let me get out my highlighter here, let's see, I'm going to remind us that our n in this case was 96. That means that our degrees of freedom is 95, 96 minus 1. Well, we don't have a 95 degrees of freedom. Degrees of freedom are all over here. So somewhere between 90 and 100, if you notice, these t-values are not very far apart. 2.632 and 2.626, they're pretty close to each other. So we're going to do some estimating. Now here's what I want you to notice, because this is very difficult to know where to go from here, because our t-value was, for our test statistic, negative 5.3072. So let's first consider the positive t-score, positive 5.3072. And notice that that t-value is whoa, I'm in the wrong spot, way off of this chart. So between 90 and 100, we're way over here on the far left column because it's much bigger than the 2.6s that we see to the right. So if you travel up that column, if we scroll up a little bit, remember we were way over here, what that tells us is that our p-value must be smaller than 0.01. Now I can plug it into my calculator and find it, but all I really care about is it bigger or smaller than the significance level? Okay, so that's how you find your p-value if you're using the chart instead. I can post technology-related stuff later, but I wanted to make sure you can do it without the technology. So let's go up here. Let's remember that our p-value is less than 0.01 and go back to our problem. So let's see, our p-value we figured out, which remember we got using our test statistic. Our p-value is less than 0.01. Okay, so if you are using my open math for this problem, I'm sorry, giving you headaches. If you're using my open math for this problem, this right here where you're entering in the p-value is a drop-down box, and the p-value is less than 0.01 will be one of your choices. Okay, conclusions. Remember, what we're talking about here, if you remember to back to what this looks like, we have a two-tailed test. And in a two-tailed test, these are our critical regions. Each one of them. And it's in those regions that we would reject the null hypothesis. Those areas right there, let me switch colors here. This would be, since it's two-tailed, the area right here would be alpha over 2 for each of them. And if I remember right, our alpha in this was 0.02. So since alpha is 0.2, I misspoke. Then we need to know if we're in one of these two critical regions. Well, if the area that we get our p-value is smaller than our significance level, alpha, then we would be in one of those two regions. So each one of those, these would be, by the way, each one of those would be 0.1 because we're dividing them by 2. Alpha over 2 would be 0.1. But those, let me fix that. Those would be less than, the 0.01 that we got would be less than the 0.1 we have for our alpha over 2. That means that we are in the critical region. So our 0.01 is in the critical region, which would mean we reject the null hypothesis. So remember, you always reject the null hypothesis if you're in the critical region. Okay, let's remember what that meant, because I know I have forgotten where we started. So our null hypothesis was here. It was that the mean is equal to 495. The mean was equal to 495. We need to reject that, which means that the opposite is supported. Well, the opposite happens to be our claim. So our conclusion would be that we have the claim that, let's see, how did they phrase it? The claim that the mean score of non-native English speakers is different than 495, or than that of English speakers, is supported.